Teshidelek. So till now we had completed 2 chapters, first and second chapter of the syllabus. So before moving on to the next chapter, I wanted to quickly discuss on the syllabus so that you get a clear idea of how many chapters do we have in a syllabus. Okay, so first I will just write down how many units we have in our syllabus. So the first unit we have is relations and function. Okay, and in this unit we have 2 chapters which are the first chapter, that is relation and function, and second we have inverse trigonometric function. So these 2 chapters comes in the first unit, that is relation and function. Second unit we have is matrices and determinant. So this is the second unit in which we have 2 chapters which are, first we have matrices and second we have is determinant. So these are the 2 chapters we have in this unit. So this is second unit. Okay, and then in the third unit we have calculus, in which we have 5 chapters which are continuity and differentiability. Second we have is application of derivatives. Third we have is integration. And then we have application of integration. And then we have differential equations. So this is the third unit in which we have 5 chapters. Okay, and in the fourth unit we have vectors and 3-dimensional geometry. So we have 2 chapters. One is vector algebra, and then we have 3-dimensional geometry. So these 2 chapters are in this unit, fourth unit. Okay, then we have fifth unit, that is linear programming problem. So this unit, we have the unit itself is a chapter. Okay, so linear programming problem, this chapter, it is one whole unit. And then we have 6th unit, that is probability. So these are the 6 units we have. Okay, so probability, that is one chapter which is itself one unit. Okay, so we have these 6 units. Unit 1, 2, 3, 4, 5, 6. Okay, now as per the latest CBSE instruction, they had made some changes in the syllabus, but that changes is very small. They had removed only one small topic from this chapter, probability. Okay, rest is same as per till date, right? So this is the changes they had made, but in future if they made another some changes, then I'll keep you updated. But right now till date, the only changes, they had removed one small topic from this chapter. Remaining is same. Okay, so now we had completed this first unit, that is relation and function. We had completed these 2 topics, right? So 2 chapters. Now instead of starting from the second unit, I'm going to start with the third unit, calculus, because these 2 units are directly related, right? So right now it's fresh that we had studied this unit, so you are clear with all the concepts, right? So therefore after this unit, directly I'm going to start calculus. Okay, so this calculus unit, it carries 44 marks, and this unit, it carries 10 marks, right? So these two unit almost carries half of the syllabus, right? So therefore these two are very important units, right? So I'm going to start with the third unit. So today I'll be starting with the first chapter, that is continuity and differentiability, right? So I'll start from the third unit. So in total we have 2, 4, 9, 10, 11, 12, 13. So we have 13 chapters in a syllabus, right? And which are divided into 6 units, but we have 13 chapters, okay, out of which we had completed 2 chapters. So we are still having 11 more chapters, right? So now I'm going to start with the first chapter of the third unit, that is continuity and differentiability. So today we will be starting with this unit, okay? Okay, now to start this chapter, I just want to ask you one question that you had studied in class 11. Okay, what do you remember in limits? There is one chapter, limit, in the class 11. Okay, so you were introduced with the definition of limit and some basic concepts of limit in class 11. So we will be needing that concept in this chapter, continuity and differentiability. Okay, so we are going to start with the first chapter with of the calculus unit, that is continuity and differentiability. So here in this chapter, these are 2 different topics. Continuity, it is one different topic, and differentiability, it is one topic. Okay, in both of these topics we need the concept of limit. We have to apply the concept of limit in these 2 topics. Okay, so before starting with the continuity, today I'm going to recall all the things which you had already studied in class 11 on the concept of limit. Okay, so first you should be clear with what do we mean by a limit of a function. Okay, so now you had already defined a limit in class 11. Okay, so now we just want to recall. So graphically I'll try to show you what do we mean by limit, right? So now we have a function fx, okay, so which I can write it as fx is equals to y. So we write it like this. So now what do we mean by f of x? What do we mean by f of x? It is the image of x, right? So that is, if I again show you with the help of arrow diagram, so say my function f is from set A to B, right? If I take my element x in the first set, then I will get a unique image in set B, which I denoted by f of x. Usually we write just y, is it? So now f of x is the image of x. Okay, so we say that when we take the 2 variables x and y, we say that y is the dependent variable because it depends on the value of x. X is independent, right? So x can take any value from the set A, and corresponding to each x, okay, you will get one unique image. So this is how we define a function. Okay, so f of x, when we write f of x, it is the image of x under the function f. Okay, so now when we are talking about the limit, then how do we define a limit? So first, before defining it, you just understand. So we take the value of x, okay, on x-axis, and we take the image on y-axis. So graphically we'll try to see. Okay, so we take the independent value on x and we take the image, its image, that is y or f of x on y-axis. Okay, so now if I define my function fx as 2x, let this be a polynomial function. I'll take one, this is one example. Okay, so now here we have f of x is equals to 2x, which means if you take element x here, its image will be here. When I take x, you get image here. This is 2x, right? Now this set can contain any element. So suppose if I have 1 here, then its image here will be 2 into 1, that is 2. Its image is 2. If I take here 2, then what do I get here? 2 into 2, that is equals to 4. So 4 will be its image. If I take 3 here, then what do I get here? 2 into 3, that is 6. So this is how my function is defined, 2x. Okay, so you can see that the value of fx or the value of y, it depends on the value of x. As you change the value of x, you get different values for y. So we say that y is the dependent variable and x is the independent variable. Okay. So now if I take f of 1, then what do I get? 2 into 1, that is 2. Okay. If I take f of 1.5, then what do I get? 2 into 1.5, that is 3, right? If I take f of 1.6, then what do I get? 2 into 1.6, that is 3.2, right? If I take f of 1.7, then what do I get? 2 into 1.7, so I get here 3.4, right? Similarly, if I take f of 1.8, then what do I get? 2 into 1.8, so that is 3.6. If I take f of 1.9, then what do I get? 2 into 1.9, so that is 3.8. If I take f of 2, then what do I get? 2 into 2, which is equals to 4, right? Okay, now you can see at first I had taken x is equals to 1, then I had taken 1.5, then I had taken 1.6, which means I'm moving my x from starting from 1, okay, to, now you can see x is 1.5, or you can here also consider f of 0, so that is 2 into 0 is equals to 0, right? So 0, 1, 1.5, 1.6, 1.7, 1 point, which means my x is moving from 0 to 2, right? So x is moving closer and closer to 2. This is how we use the term when we are going to define the limit, okay? So here you can see that my x is moving from 0 and it is moving closer and closer to 2, right? So you can see that as x is moving closer to 2, right, the value of y, now this f of x means it is the value of y, or f of x you can say. As x is moving closer to 2, f of x is also moving 0, 2, 3, 3.2, 3.4, 3.6, 3.8 and 4, right? So you can see that as x is moving closer to 2, your f of x, that is the image of x, it is also moving closer to certain point. In this case, it is moving closer and closer to 4. You can see first it was 2, 0, then it was 2, then 3, 3.2, 3.4, 3.6, 3.8. At most, when x is 2, then it is equals to 4, which means as x is moving closer and closer to 2, your f of x is moving closer and closer to 4, right? So first you understand this. So I'll try to show you here. Say this is my 1 and this is 2, and here we have this is 1, 2, 3, and I'll extend this and I'll take it here 4, right? So okay, now when my x is equals to 0, f of x is 0, right? Okay, and my when x is equals to 1, my f of x is equals to 2. When x is 1, f of x is, when x is 1, f of x is 2. So that is 1, 2, right? So when f of x is 1.5, okay, so it was 3, okay, and when when x is 1.6, it is 3.2, right? So here you can see when x is 3.5, 3.6, 3.7, 3.8, 3.9. So then it is when it is 3.7, then it is 3.4, then it is 3.6, then it is 3.8, and then it is 4, right? So you can see this is my graph. It starts here. So you can see that you get this graph, okay? Now what you can see is as x is moving closer to 2, as x is moving closer to 2, you can see that f of x, its image is moving closer and closer to 4. You can see that as x is moving closer to 2, your f of x, that is the image of x, it is moving closer and closer to 4. Here in this case, it is moving closer to 4. As x is moving closer to 2, f of x is moving closer to 4, right? So then we say that as x is moving closer to 2, f of x will obviously move towards certain point. So that point where fx is tending towards, that point is called as the limit of the function when x is tending towards a point. So here in this case we are taking example as 2. So for this example I will say that as x tends to 2, f of x tends to 4, right? So therefore 4 is the limit of this function. So 4, when we say limit, so limit is the point to which your function or the image of x is tending towards as x tends to a certain point. Okay, so now with this example you can understand what do we mean by the limit. So as your independent variable x tends to certain point, as x tends towards certain point, f of x will tend to certain point. So this point is called as the limit of the function, right? So if you remember, we write like this. So we write limit of fx, okay, so limit of fx as x tends to, here as x tends to 2, so this is equals to 4. You write it like this, okay, or you can say limit of fx as x tends to a. So a is any point on x-axis where x is tending towards. So you will get, so when x tends to a, f of x will tend to a certain point. Obviously that will happen. So that point, say let it be L. So this L is called as the limit of the function. So this L is called as the limit of the function. Okay. So now in this example we can write limit of, here what is your f of x? It is 2x. So limit of 2x, function fx is 2x here. So limit of 2x as x tends to 2, here x is tending towards point 2, then you can see that as x tends to 2, f of x tend towards 4, right? So we say that 4 is the limit. So that happens for every function, right? So as x tend towards certain point, obviously its image will tend towards certain point on y-axis. So that point is called as the limit of the function. So we write it like this. So limit of fx as x tends to a. So x tends to a means x is tending towards a point on x-axis. So as x will tend towards a, your f of x, what is f of x? It is the image of x. F of x will tend towards certain point. So that point is called as the limit of the function. So this is how we define limit. Okay. Okay, now after defining limit, now if you remember, you might have checked the existence of limit. Then the next topic on limit comes existence of limit. Okay, so these all are done in class 11. Now since we need all these concepts in here, this chapter, so therefore I'm revising it. Okay, after defining limit, then we have the existence of limit. After defining limit, then we should know the existence of limit. Okay, now when do we say that a limit exists or a limit does not exist? Okay, so now now we are going to use the definition of limit. Okay, so here in the previous example we had taken point 2. Okay, so we had written x tends to 2, x is tending towards 2. So when x tends to 2, f of x will tends to certain point. Now when I say that x tends to 2, x can tend towards 2 in two ways. Either x can tend towards 2 from left hand side. First x is somewhere here, then here, then here, 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 here. So x is coming nearer and nearer to 2 from left hand side, right? The other way is also x can come towards 2 from right hand side. So first x is somewhere here, then it is here, then here, then here, then here. Here also x is moving towards 2 and here also x is moving towards 2 but in opposite direction. Okay, so both ways are correct, right? So x can tend towards 2 from left hand side as well as x can tend towards 2 from right hand side, right? So when x is tending towards 2 from left hand side, okay, then your f of x will tend towards certain point. Similarly, when x is tending towards 2 from right hand side, then your fx will also tend towards certain point. So when the left hand side, when x is tending towards 2 from left hand side, you get one limit at that time. And when x is tending towards right hand side, you get one limit. If the two limits coincide, which means if the two limits are equal, then we say that the limit of the function exists, right? If you get different limits, when x is tending towards 2 from left hand side, you get a different limit, and for when x is tending towards 2 from right hand side, if these two limits are not same, if they are different, then we say that limit of the function does not exist. So when we find the limit when x is tending towards 2 from left hand side, then we call it as left hand limit. And when x is tending towards 2 from right hand side, and that time when we find the limit, that is called as right hand limit. So if left hand limit is equals to right hand limit, then we say that limit of the function exists. Otherwise, the limit of the function does not exist. Okay, so we'll look at the previous example. I taken my function f of x as 2x, I guess. Okay, so if I write okay, it's very simple. First we'll just understand this. Say this is my 2, right? This is the limit point. It's called as the limit point at which your independent variable is tending towards. So 2 is the limit point. Now x can tend towards 2 from left hand side, as well as x can tend towards 2 from right hand side. So my function is defined as 2x. F of x is equals to 2x. Okay, so now first I will take certain points on the left hand side and see what do I get for left hand limit, and then I'll take certain points on right hand side, and then I will find the right hand limit, and we'll check whether I get the same value or not. Okay, so let it be 1, 2, 3 and 4, 5. I'll take one more point, that is 6. Okay, now first I'm going to take on two different sides. For left hand limit, I will take some points on the left hand side. So I'll consider only those points which are very close to 2, right? So which will give us an accurate limit. Okay, so first I will take f of 1.5. So 1.5 is somewhere here. I'll take yes, 1.5. So what do I get? 2 into 1.5. So that is equals to 3. Then I'll take 1.8, which I get 2 into 1.8. So that is 3.6. And then I'll take f 1.9. So that is equals to 3.8. And at most you can go up to 2. At most you can go up to 2, not beyond that. Okay, so f of 2 is 4. So I can see when I take 3.5, I get value image as 3, right? Okay, then when I take x is equals to 1.8, I get 3.6 somewhere here. Okay, and then somewhere here. So I get this. So you can extend this, right? So you can see that when x is tending towards 2 from left hand side, first you had taken a point over here, then you had taken a point over here, here. So you can see that it is tending towards 4, right? So my left hand limit is equals to 4. Okay. Similarly, now I'm going to consider a few points on the right hand side so that I can find out right hand limit. So first I will take here, so 2.5. I'll not go too far from 2, okay, because I have to come nearer and nearer to 2. So I will take a point nearby 2 so that I can accurately get a limit. So first I will take 2.5. So my function is defined as same. So therefore f of 2.5, what do I get? That is equals to 2 into 2.5, that is 5. Then I have to come closer to 2. So I have to decrease the point. Then I will take 2.4, okay. So f of 2.4, what do I get? I get 4.8. Then I'll take f of 2.3. So what do I get? That is 4.6. And then I'll take f of 2.1, which is 4.2. And then I'll take f of 2, which is equals to 4. So on the right hand side, when you plot the graph, you will see that it is also tending towards 4. Okay. So when left hand limit is also tending towards 4, right? And right hand limit is also equals to 4, which means the limit of this function, it exists. Is that clear? So this is how we check the existence of the limit. So when we say that, when we simply define the function, we say that when x is tending towards certain point, f of x will tend to a point, and that point is called as the limit of the function. So this is the general definition of limit. But when we check the existence of limit, then we have to do in two ways. First, you will find the limit when x is tending towards that point from left hand side, and then similarly you will find the limit for the function fx when x is tending towards that point from the right hand side. Okay, so if these two limits coincide, if these two limits are same, then we say that the limit of the function exists, otherwise it does not exist. So this is how we check the existence of the limit. Okay, now I don't know how you might have did or how you use the method to check the existence of the limit. So I will not go in detail. I'll just show you one example. Okay, I'll give you this example. We will solve this together. Check the existence of the limit of the function f, which is defined by f of x is equals to, if I write x square plus 1 when x is less than or equals to 1, and I'll write 2 when, or I'll just write x plus 1 when x is greater than 1. Okay, at x is equals to 1. Okay, now this is your question. Check the existence of the limit of the function f, which is defined by f of x is equals to x square plus 1 when x is less than or equals to 1, and f of x is equals to x plus 1 when x is strictly greater than 1. And you have to check the existence of the limit at x is equals to 1. That is the limit point. Limit point is given as 1. In the earlier example, we had taken a limit point as 2. X is tending towards 2. Okay. So when you are asked to check the existence of the limit at x is equals to 1, which means you have to find out the limit when x is tending towards x is tending towards 1 from left hand side, and you have to find the limit when x is tending towards 1 from right hand side, and then we'll see whether these two limits are same or not. Okay, so first we have to find out left hand limit. Okay, so this is equals to, okay, now you look here, we write it like this. When we are finding out the left hand limit, then we write limit of the function, any function. Okay, or you just write limit of function fx as x tends to 1, right? Now if I just write x tends to 1, then this is the standard way. Okay, now here, since we are finding out left hand limit, we have to precisely write what is this x tends to 1. So we will write x tends to 1 raised to, you will write a negative sign here. Okay, so when I write x tends to 1 raised to negative, this means x is tending towards 1 from left hand side. So you remember that. So when x is tending towards 1 from left hand side, so this is the function. So now here my function defined in two ways. When the x is less than or equals to 1, then your function image is x square, or image of x is x square plus 1. Okay, when x is strictly greater than 1, okay, then your image is x plus 1. Okay, so this is how my function is defined, and I'm quite sure you are familiar with the representation of function in this type. Okay, so I think you will not face problem if I give you directly a question on this. Okay, now since my x is tending towards 1 from left hand side, now let me take it like this to explain. Let it be 1. Okay, now please remember that whenever we are finding out limit, when we say x is tending towards the limit point, then x is going very near to 1, but x is not exactly taking the limit point. You remember that x is tending towards 1, which means between any two real number there exist infinitely many real numbers. So x is going very near to 1. Okay, so you have to consider all those points which are nearby 1, but not exactly 1, because x is moving closer and closer to 1. When I say that, so first if I say x is at, okay, let me take, this is 1. So this is 0.9. This is 1. So can you see that 0.9 is nearest to 1? No, because there lies infinitely many points between these two. So you may think of 0.99, okay? Still, this is not the nearest point. Then you can take 0.999. That becomes more closer to 1, okay? So likewise, you will get infinitely many points between any two small real numbers, right? So therefore, you have, when you are saying that x is moving towards 1, you have to consider all those points which are nearby 1, not exactly 1, okay? So now we can say that when x is moving towards 1 from left hand side, when x is moving towards 1 from left hand side, x may be very near to 1. But in this case, x is always less than 1. So you remember that, okay? When x is moving towards 1 from left hand side, so x is somewhere here. First x may be here, then here. So it will move closer and closer to 1, but it will not cross 1. Which means in this case, when you are finding out the left hand limit, your x will be always less than 1, okay? So now we have a restriction on the function. So when x is less than 1, now when you are finding the left hand limit, your this nature of x, it comes in this restriction, okay? So in that case, your function image f of x is x square plus 1. So therefore, I will write limit of x square plus 1 when x tends to 1 from left hand side. So this is the correct way of choosing the function. So you know that whenever you are finding out the left hand limit, x is always less than, okay, very close to the limit point, but it is always less than the limit point, okay? So according to that, you have to choose the function. All right, so now we have limit of x square plus 1 as x tends to 1 from left hand side. So this is my function, okay? Now we will discuss this, how do we check the existence of limit in the full way, because this whole concept is needed in this topic, continuity. So you must be thorough with this topic. So today we will just spend time on checking the existence of limit. If this part is done, then almost 90% of the concept is cleared from this topic, continuity, right? So today we will spend time on understanding how can we check the existence of limit, right? Okay, now how we will find the limit. Now we know that when you are finding out the left hand limit, so x is always less than 1. I've shown you in that number line, right? So x is very close to 1, but it is less than 1 because x is on the left hand side of 1, so it is less than 1. Now to show that x is less than 1, okay, x is less than 1, what I will do is I will make a substitution method here. So I will write let x is equals to 1 minus h, okay, 1 minus h, where h is some small positive real numbers, okay? So just to show that x is less than 1, okay, I'm making this substitution. Let x is equals to 1 minus h, but I have to define what is this h. H is some small positive real number. If I don't write this, okay, so if you subtract a positive real number from 1, if you subtract a small positive real number from 1, then obviously this value will be less than 1 because you are subtracting some positive number from 1. So the remaining, the difference will be always less than 1, right? So just to show that x is less than 1, I'm making this substitution. Now what happens if I don't describe what is this h? If I don't write h belongs to some positive real number, then h can also be some negative real number. So if h is a negative real number, then 1 minus some negative real number, it means you have to add them. So it will be greater than 1, which contradicts this, right? So therefore always you have to describe what is your h, okay? So that is x is equals to, now since my x is less than 1, to show that I'm using this, let x is equals to 1 minus h, okay? So if x is equals to 1 minus h, right? So now x is tending towards, okay, as x is tending towards 1, now this is actually the thing. So this is my 1, okay, this is somewhere you have this, x is somewhere here. Now what is this h? H is the difference or the length of the interval between x and 1, okay? So as x tends to 1, as x tends towards 1, what will happen to this interval h? It will decrease, right? So at most x can reach 1, but it will not cross 1 because x is always on the left hand side of 1. Okay, so as x tends to 1, as x moves closer to 1, the interval, the length of the interval which is given by h, this h is the length of the interval, so h will tend towards 0. As x move, or as x tends to 1, h will tend towards 0. So you will make this substitution. Okay, so now I can put it here. So I just want to eliminate this, so for that I will write now I will make this substitution. Instead of x, now I will write 1 minus h. Instead of x, I will write 1 minus h, x square. So therefore I will write 1 minus h whole square plus 1 plus 1. Okay, now as x tends to 1, h tends to 0. Is it? So I'm just converting x in terms of h. Okay, so now everything is now in terms of h. Your variable is in terms of h. Your limit point h is also tending towards 0. Okay, so in class 11, to evaluate a limit, there are certain few methods. We have direct method, we have factorization method, we have. Okay, so here you can directly substitute the limit point here. That is a direct method of evaluating a limit. So you put h is equals to 0 here. So what do I get? Now always remember that when you substitute the limit point, then you will stop writing this limit. Okay, till you are substituting the limit point in the variable, you have to continue writing this limit of the function as h tends to 0 or whatever limit point you are given. Okay, so now when you substitute it here, so then you will not write a limit. So I'm substituting it here 0. So then 1 minus 0 whole square, that is 1 square plus 1, so that is equals to 2. Now this is my left hand limit. Okay, now I want to say that directly from here, without making this substitution, okay, without making this substitution also, you can substitute 1 here and you will get directly 2, right? But the direct evaluation of a limit exists only for polynomial and some special functions. Okay, whereas when you consider modulus function and when you consider greatest integer function, for these functions to check the existence of the limit, without applying this substitution method, you won't be able to check the existence of the limit of those functions. Okay, so therefore I suggest you to always use this method while evaluating the left hand limit and right hand limit, so you will get a clear concept of how we have to solve it with okay. So after this you have to write this. After writing this, so you will write let x is equals to 1 minus h. So we know why we are writing 1 minus h, since x is less than 1. So to show that x is less than 1, I'm writing 1 minus h, where h is some positive real number. So when you subtract a positive real number from 1, x will be obviously less than 1. Okay, so and as x tends to 1, h is actually the interval between, length of the interval between x and 1. So as x tends to 1, as x move closer and closer to 1, the limit length of the interval h, it will tend towards 0. Okay, so after this making substitution, so you will convert everything in terms of h. So instead of x, you will take 1 minus h whole square h and everything. Okay, now we will find right hand limit. Okay, now to find right hand limit. Now if you understood how do we find left hand limit, then obviously it's same for right hand limit. So I will write limit of fx as x tends to 1 from right hand side. Now this is how we denote left hand limit and right hand limit, because these two are different. If you just write x tends to 1 only, then it is not specified whether you are moving towards x from left hand side or right hand side. So to specify that, you will write 1 raised to negative, so which denotes x is tending towards 1 from left hand side. Okay, so when you write x tends to 1 raised to positive, then it means x is moving towards 1 from right hand side. Okay, so this is the difference. So now when you have, okay, say this is 1, now x is somewhere here, x is moving towards 1 from right hand side, so which means x is somewhere here. Okay, So as you take x very close to 1, but in that case also x is always greater than 1, because on the right hand side number is always greater. Okay, so you will see that when x is moving towards 1 from right hand side, however you take a very x very close to 1, but still you will get x is greater than 1. Okay, now our function is defined as when x is greater than 1, then the image of x is x plus 1. Now you have to choose this function instead of this. Okay, so here I will write limit of, now in this case my function will be x plus 1 when x is tending towards 1 from right hand side. Okay, so now again I'll make the substitution here. Now in this case x is greater than 1. So to show that, I will write let x is equals to 1 plus h, where h is some positive real number. So when you add a positive real number on 1, the sum will be obviously greater than 1. Okay, so just to show that x is greater than 1, I'm making this substitution. Okay, so say x is somewhere here. So x plus 1 plus h means x. So h is the length of the interval. So as x tends to 1, okay, h will tend towards 0. So you write it here. So this is equals to now limit of, now instead of x I will write 1 plus h. 1 plus h, x, instead of x I taken 1 plus h, you take down plus 1, this plus 1 here, and as x tends to 1, now instead of this I can replace with h tends to 0, right? So now you can directly substitute it here. So you will write here, this is 1 plus 0, that is 1 plus 1, so we get 2. Okay, now what do we have? Left hand limit is equals to right hand limit. So left hand limit we got 2, right hand limit we got 2. Okay, so therefore limit of this function exists. So in this way you will check the existence of the limit. So at last you have to conclude this. Therefore limit of function as x tends to 1. Now you just write 1. Okay, so limit of the function fx as x tends to 1 exists. So this is how you will conclude. Is that clear? If you are getting left hand limit and right hand limit different, then you will say that limit of the function as x tends to 1 does not exist. So this is how you will check the existence of the limit of the function. Now this is the topic of class 11, and I'm just revising it because this whole concept is needed in this topic. Okay, continuity. So therefore we spent time to understand this concept, right? So today I will stop here. Okay, and as assignment you will do exercise 5.1. In exercise 5.1 the questions will be given as check the continuity. So you, instead of that, you will consider check the existence of the given function, right? So in that way you will solve exercise 5.1, and you will just consider those questions as to check the existence of the limit of those functions. So if the question is asked as check the continuity of the function, then you will skip that question and you will change that question to check the existence of the limit of the function, whatever function you are given. Okay, so in the next class we will continue with the topic continuity, and if you are clear with this concept, the existence of the limit, then almost 90% of the concepts are cleared from this topic. Okay, so there is 10% more new things to learn. On almost 90% you had already learned if you are clear with the concept of the existence of limit. Is that clear? Okay, so from exercise 5.1 you will do 3 or 4 questions just to check the existence of the limit instead of checking the continuity of the function. Okay, so I'll stop here and I'll see you in the next class. So till then, take care and stay safe. Thank you.